I often find myself, well, doing exactly this, laying around daydreaming about random stuff, current projects, future projects, materials, techniques, the meaning of life, the really important stuff. And so one day when I was very hard at work doing absolutely nothing, I fell down a brain rabbit hole that is chemically etching metal. Like I said, random, but actually could be kind of cool. Or at least in my mind it is. Never actually done it before, but I feel like if we use 3D printing, it's gotta turn out dope, or at least easy, maybe even both. And actually, for once, I'm doing this at the beginning of the video and not the end, so it could actually just end with chemical burns in the ER. Probably make for a better video. Stick around. The basic idea behind chemical etching is pretty straightforward. We have two major parts to it, our metal and our etching. The only thing we need to make these two things work together though is some sort of resist or mask layer that's going to control the etchant and keep it from going places we don't want it to go. And in my daydreaming, I was like, wouldn't 3D printing work great for that? Like, all we gotta do is print off this little stencil, plock it on with a clamp, pour in the etchant, and that's it, we should be done. Well, now that I've had a little bit more time to think about it, I'm not so sure about that now. That's probably why I printed a lot of different varieties. One of these has gotta work. The whole crux of the issue is pretty straightforward. Well, we need these prints to make a watertight seal with our part, otherwise the etchant will just leak all over the place. And while 3D prints are pretty darn flat, even the smallest crack and crevice can lead to problems. So, to give these a jump start, I think I'm gonna hit them with a little bit of sanding paper first, really flatten them, give ourselves an advantage. So, our test is all ready to go. We clamped her down, gave it a quick wipe with some acetone, and now all we gotta do is fill the print up with our etchant. Now the etchant in question is ferric chloride. It's typically used for PCB manufacturing and etching away and creating the traces. It's readily available, easy to acquire, cheap, and it's not like the most dangerous thing in the world. We're just gonna gently add our etchant, and hopefully it doesn't leak everywhere. All right, let's just give it, 5, 10, 30 minutes, see what happens. I feel like it's leaking. I don't know, maybe this works, who knows? We're just gonna neutralize it in a little bit of baking soda and water. Ooh, it did something. It did something. Look at that. Oh, look at that. It actually worked. No way. All right. I mean, yeah, it worked. That's impressive as hell. What do I need all these other 3D prints for? Video done, it works. Okay, so it's been a minute. The last time you saw me, I was absolutely exuberant over the fact that my first test actually worked. I mean, that just never happens. And it came out pretty darn clean. Ignore all that rust and crud and whatnot. I've subsequently done like a dozen tests and I keep spilling ferric chloride absolutely everywhere. Now, despite that success, I don't think the clamping method is gonna be the right one. Certainly it worked for this small part, but the bigger we get, the harder it's gonna be to get even clamping pressure. So to try and eliminate it, I thought it was being smart and applying a thin layer of CA glue to the bottom of the mold. The idea here is the CA glue will hold it in place, but also fill in any of those microscopic valleys and hills and prevent it from leaking. Or at least that was the idea, because the first test leaked immediately, leaked to the point that I actually thought the etchant was eating away at the CA glue. But further testing proved that to be absolute bupkis. So I just rolled right along, doing 3 tests this time, but instead of thinning it down with acetone, I didn't, and I applied clamping pressure using a good old-fashioned Blocko steel. And yeah, those went better than the first one, but still not good. 2 out of the 3 leaked, and the one that didn't came out a little bit fuzzy on the corners, which tells me we're not getting a complete seal. But I don't give up easily, so I rolled right along and I took my next mold, which was made out of ABS. The idea here is I apply it down onto a bed of acetone. The acetone will fuse/melt the ABS directly onto the part. This is actually like a super old school 3D printer technique where people used to make their own bed adhesive. And it totally works. It sticks to the part real darn good. What doesn't work is the etching. It doesn't leak, but it came out even fuzzier than the CA glue, which tells me the acetone is pulling into the center and then slowly eating away at the edges, creating a sort of undercut effect. And at this point, I was getting kind of worried, like, is this gonna work? So I actually went back to the clamp, but this time I used one of my TPU molds. You know, TPU is used in industry for seals and other whatnot all the time, so it's gotta not leak, right? Yeah, no, it leaked immediately. Worst one of them all. So I just went full circle. I literally just went back to the first test part and ran it again just to make sure I'm not absolutely insane. And no, I'm not. It came out pretty darn good, which is hilarious because at the beginning of this video, I thought that there was no way that this clamping method was gonna work, and I thought that there was no way that the other ones weren't gonna work. But in reality, complete opposite was true, which just makes me question everything. At this point though, this whole technique is dead to me. I'm done with it. Sure, 1 out of 10 worked, but it has a major downfall, and that's actually getting the etching out of the mold. Surface tension is really fighting us here, and even with the clamp out of the way, it's an absolute pain in the arse. So I decided to go back to the drawing board. Conventional etching, at least in the PCB world, is done by applying a resist layer in the form of your design. Old school way is using heat transfer paper, new school way is a UV photoresist and then a UV light to cut out the design. We're not gonna do any of that. Instead, we're gonna 3D print a negative stencil this time. We'll then airbrush on our resist layer, and then anything that's covered by the stencil will get etched when we submerge the entire part into the etchant, which should solve and does solve all of our problems, but you know, it just creates a whole bunch of new ones. My first idea was to airbrush on dykem or layout fluid as the resist layer. But then, you know, I did some digging on the dark underbelly that is Reddit, and apparently a regular Sharpie does the trick, they say, which sounded so much easier, and it would have been if they weren't absolute liars, because it does not work. It washes off after like 5 minutes in the ferric chloride. So I went back to Reddit and found out, oh no, you don't want the regular Sharpie, you need the expensive industrial Sharpie, a bunch of people say. That's the one that works. And yeah, again, liars, because this one actually worked worse than just the regular Sharpie. So I go back again, and this time dozens of people saying that, oh, you need the Staedtler Lumacolor pen. That's the ticket. Sure, it costs $10, but it's totally worth it. And once again, liars. I mean, it worked the best of them all, but it still didn't work. And, you know, maybe if you applied like 4 or 5 coats of it, it could last long enough for the etchant, but that kind of defeats the whole purpose of the marker being easy. That said, you know, like a bad relationship, I'm not willing to give up on it just yet. Mostly because I kind of already decided on the thumbnail and title of this video, and there's no way I'm changing it. But, you know, while I was in the throngs of Sharpie Gate, I decided to give the old airbrush a whirl. Here, we're going to apply a thin layer of PVA glue to the back of the stencil and glue it right onto the part. We can then airbrush on thin coats of both dykem and a lacquer-based nail polish, which was also a Reddit suggestion, and both laid on beautifully. The dykem though, well, it started to peel off almost immediately, and I'm like, what gives? This stuff is supposed to be applied to metal, and it didn't fare much better in the etching. I mean, it came out okay, but it's just not reliable enough for me to trust it. And at that point, I was honestly about to give up until I saw the nail polish test. And finally, after weeks and dozens of tests, we have one that is better than our first test. A low bar, I know, but hey, it's something. And it's not perfect, but man, are we actually pretty darn close to acceptable. And I think we can get there. There's a few things we can improve. The stencil is like 0.5 millimeter thick, but with resin printing, we can get quite a bit thinner. I also was a bit heavy-handed with the airbrush, and I don't think I got the consistency quite right on the nail polish. It needs to be a bit thinner. That said, I'm kind of burnt out on the whole testing thing, so I decided to shelve it at least for a second and actually make something. In this case, a toolmaker's clamp. You know, a classic apprenticeship project, and one that I think will present a very unique opportunity for etching. First things first though is we gotta cut and square up our stock, which in this case is 4140 pre-hard, which comes in right around 25 Rockwell C. So hard enough that it's not gonna get wallered out from day-to-day use, but soft enough that we can still machine it with just conventional cutting tools. In this case, I'm using a high-speed steel fly cutter, which, unlike carbide, isn't quite as shiny and bright, but it has a really unique and appealing texture, at least to me. The other features are a couple tapers. Here we're doing 15 degrees on the top and a very subtle 3 degrees on the side. The rest of the accoutrement are a couple holes and a full round on the back. The full round presents a really great opportunity for me to bust out my 3D printed rotary fixture table, which I made in my last video. Pretty good video, and it worked pretty darn good here. In fact, my milling machine gave me more lip about the depth of cut than the rotary did. Now that said, it didn't actually come out perfect. Something was wrong in my setup or my fixture because I wound up cutting heavier on the left side than the right side, which means I couldn't take it to a full round without risking introducing a scallop into the side. But, you know, that's something we can fix in a minute or so. We'll talk about that. But let's talk about the most interesting part of this, which is going to be the etch, or at least I think so. The idea here is to do a 360-degree etch. We're going to start at the tip, go across the taper, all the way the back, around the curve, and back to the front tip, creating this sort of 3D effect in a sense. I've never seen this done before, at least in etching, and I certainly have never seen it done on a toolmaker's clamp before. So, fingers crossed worlds first. But to get there, you know, we actually still gotta figure out the whole etching process. But hey, we're close. We're close, I swear. Okay, I gotta stand up for this one. It's been a real doozy. I should have just given up on this whole pen idea long ago. But the nail polish, it just works so well. If we could just find a pen that has the same medium, we would be golden. And I know they make, or at least manufacture, pens that are specifically for etching, but honestly, they all just look like rebranded Sharpies, and we know exactly how well those work. So instead, I tried my hand at lacquer-based paint pens. After all, the lacquer-based nail polish worked, and well, it was a Reddit suggestion. Yeah, I just keep coming back. But the test samples came out really good this time, so much so that I just dove right into an actual project. I have this cheap set of angle blocks that has laser engravings on it that are almost invisible to the naked eye, so let's fix that. Oddly enough, the Sharpie paint pen was the best of them all, but they all just kind of sucked, even the Sharpie one. They all just pool and flow way too much ink. It smears and gets in the corners, and it's just an absolute disaster. Even with the Sharpie pen, you gotta be crazy fast to get a good result. That said, you can kind of touch it up after the fact with an X-Acto blade, so it's not all negative. I did want to try my hand at some freehand work as well, so I did some cross-hatching just for the giggles. The actual etch process, super simple. Ferric chloride reduced from 40 to 10% concentration, dip it in that, then a water bath, neutralize with baking soda, wash the mask off with acetone. And our results are absolute doo-doo. Like, what is going on? There's clearly some sort of chemistry disconnect between our mild steel test sample and our angle blocks, which are made from tool steel. I eventually did get a decent result by reducing the etch time just down to like 5 or 10 seconds. Our test sample lasted a full 2 minutes, no problem. So it's not the paint pen, the mask, or something. I don't know what's going on. It's not washing away like the Sharpie did. It's somehow still getting through it via osmosis or magic, or I don't know. Honestly, I really don't. I mean, I know that different alloys of steel will react differently in terms of color and etch depth, but I have never heard of anything like this happening. And that black color you're saying, that should be there. That's not the problem. That's iron 2 oxide, which forms when it comes in contact with iron 3 oxide, or at least forms when iron 3 oxide comes in contact with iron. Iron 3 oxide is ferric iron, or ferric oxide, which, you know, is in ferric. So while past me goes off on a whole chemistry rant, future me has a confession to make. I have a problem. I can't stop buying old machinist tools on eBay. Prime example is I have a set of Lufkin mics that have just been lying around for months now, waiting for me to clean and calibrate them. But my real weakness though is homemade machinist tools, like this cute little sign bar that I picked up for like $10 years and years ago. It would have been a total steal if the sign bar actually worked, which it doesn't. It just like kind of falls over. But at the same time, I still love this thing because, well, check out that date, 1944. That combined with the engine turned finish on it really makes me think that this was made by like an Air Force apprentice back in like World War II, which is so cool, man. And just by adding like name, date, designer, maker's mark, you take things from being just a simple tool to being a story. But, you know, before we go back to the past, future me has to tell you, don't listen to that guy. Always wear gloves and eye protection when working with acid. You'll thank me. Rant is over. That said, at least now I can tell what angle my angle blocks actually are, even if some of them are a bit ugly. Now, after that whole debacle fiasco that was the pen saga, I learned my lesson. For the toolmaker's clamp, I did some test samples using the actual 4140 steel that I'm gonna use. And thank the Lord, unlike the pens, the nail polish turned out the same as before. I did 10% concentration for a full 20 minutes and they came out looking great. So it's time for the main event, but it's not time for the main event because we have one more distraction. We need to make the hardware for the clamp itself, specifically the knobs. Now, I did a quick deep dive on the internet to try and get some inspiration, and I was shocked to find out or see I couldn't find a single example of someone deviating from the traditional design, which is a small diameter with a heavy knurl and then a center hole for extra leverage. And let me tell you, I absolutely hate this design, both in terms of like aesthetics and functionality. I had the same exact knobs on a pair of Brown & Sharp V-blocks that I own, and the knob is always too small to fully tighten, the knurl is uncomfortable, and I can never ever remember where the hell I put the knob or the Allen key, drill bit, etc. for tightening the center hole. So we're gonna go a completely different route. I decided instead to use some 1/4-20 brass all thread, turned one end for a press fit that goes into the stem. The stem is made from 304 stainless. Now that press fit, I actually, by a miracle, machined it within 0.01 millimeters of tolerance, just by eyeballing it on a boring head. I mean, no joke, never in my life have I gotten so lucky. It's unfortunate that the rest of the project hasn't been going that well. Now for the knob, it's also made from brass, way too big of a piece, but you know, it's just what I had lying around, whittle it away, and then press the whole thing together. Once pressed together, we can turn the final features and dimensions. Now on the knob, that's just bringing it to diameter, facing it, and then I did a little bit of a scallop on the knob to both match the radius on the stem, but also just make it feel nicer in the hand. And it does, it feels great in the hand and looks pretty good too. You know, and gives you decent leverage. So I'm happy with it overall, which means it's time to etch. It's for the main event. And well, round one didn't go so great, at least on the stencil side. For the 3D print, I decided to do 2 halves and then bring them together on the part itself. But this turned out to be a terrible idea. It was almost impossible to get the 2 aligned even decently without getting glue just absolutely everywhere. Along with that, I'm still not getting the consistency on the nail polish correct, which led to multiple letters peeling off. But I learned some things. At 0.25 millimeters thick, the stencil is flexible enough that I can actually just print it as a flat pattern and then wrap it around the part, eliminating all of the alignment issues. Along with that, despite it genuinely being below freezing in my garage, I finally managed to get the airbrush to work pretty good. Now that said, not all perfect as usual. Some rust spots formed here and there. Clearly the water in the PVA glue is reacting with the steel, even in the short 10-minute window that they're in contact. Along with that, the stencil did lift up here and there, leading to a sort of overspray condition. kind of fuzziness in the stencil. And one other thing, that the fly cut finish I removed just on the stencil faces and opted for a more sanded / polished look. Now it's time to etch. And the etch process is, well, pretty similar to the angle blocks, but instead of just like 5 to 10 seconds, we're gonna let this thing cook for a full 20 minutes. Along with that, everything else is pretty much the same. 10% concentration. After the ferric chloride, it goes for a water bath, neutralize, acetone, and the result is not bad. Like, not perfect, but not bad. We did get a couple pinholes forming here and there, which tells me that the ferric chloride is actually eating away at the nail polish, but very slowly. This, though, actually works in our favor. Remember those overspray areas? They came out looking super crisp and clean like the rest of the stencil. Now you might be wondering right now, like, what gives? That pattern doesn't look right. They don't align correctly at all. Like, what's with the lightning bolt, bro? It's because we're not done. We still need to make this into a clamp by splitting the body in half. And if I did my math right, and we remove precisely 1/16 of an inch from the middle, the two halves then should perfectly align. Last couple things are some tapped holes and then a slot for the C-clip. And the slot for the C-clip went, well, about as good as the rest of this project has. Yeah. I mean, you can see what happened. You know what happened. But unlike my last video, you're probably thinking, loose vise. No, not in this case. In this case, it was too much stick out, too heavy of a cut, and the cutter was chipped. But to be fair, all of my cutters are chipped. The real issue was I wasn't thinking at all. It was late at night and I was focused on filming. And in my mind, I was like, oh, it'll be so much cooler looking if I take it in one pass. But I don't give up easily, so we're gonna fix this. I airbrushed just the tip using the stencil and then masked the rest off just by hand. We're gonna come in with a paintbrush and the ferric chloride and touch up all those areas that got dinged and damaged. Now, to try and keep the part from picking up future scratches, I had the bright idea of adding a 2K gloss clear coat to the part and all the other accoutrement. And yeah, that wasn't a great idea. I mean, it was good in terms of durability, but it looks super poopy. I'm not happy with it, like, at all. 5 out of 10 on finishing. Maybe like a 7 or 8 out of 10 on functionality. Some of the tolerances got a little loose here and there, but what this video was actually about the etching, 8, maybe 9 out of 10. It's not perfect. You remember we got those pinholes forming and that iron 2 oxide finish is super weak, not usable for a final product. And we didn't get the etch anywhere near as deep as I wanted it to. I wanted an actual like dimensional feel to it. But I'm pretty sure we can actually solve all of those problems in the future by simply upping our concentration from 10% back to the normal 40%. The heavier acid concentration should be able to eat away at that black iron 2 oxide finish and expose fresh metal for us to etch further down. Now, this should also create new problems in that our nail polish mask might not be able to hold up to that higher concentration as well, which means we got to try something else. And there's only one thing I haven't tried, and that's asphaltum, or at least I think that's how it's pronounced. It's an artist material. It's essentially asphalt. And so if you want to see me try and airbrush asphalt, let me know. Now, to wrap this whole thing up, the original sort of 3D print stencil pool idea, terrible. Pen idea, also terrible. Airbrush idea, pretty darn solid. I'm gonna keep that one in my toolbox for future projects, for adding things like name, date, designer, maker's mark, etc. Because like I said before, it's not just a tool then, it's now a story, which is the whole point of this channel. And hopefully you liked this story. If not, well, sucks to be you. Bye.